হ্যালো, গুড মর্নিং স্টুডেন্টস। শুনতে পাচ্ছ
Good
সবাই?
morning, sir.
শুনতে পাচ্ছ আমার
Good
Good
কথা?
morning.
morning, sir. Yes, sir.
Yes, sir, শুনতে পাচ্ছি।
Okay. So last class what we have studied about the practical, I think. Okay. Last Friday
Yes.
we have and last Tuesday we have studied about adsorption isotherm. Can you remember adsorption isotherm? Adsorption isotherm. তো আজকে তাহলে সেটা আর একটু রিপিট করে নেওয়া যাক নাকি? তারপরে কত ধরনের আমরা adsorption isotherm পড়েছি?
স্যার ল্যাংমোর অ্যাডসর্পশন আইসোথার্ম অব্দি হয়েছিল।
হ্যাঁ, কোন অবধি?
মানে মাল্টিমলিকুলার অ্যাডসর্পশন,
হুম হুম হুম।
তার আগে ল্যাংমোর অ্যাডসর্পশন আইসোথার্ম এগুলো হয়েছিল।
ফ্রেন্ডলি আইসোথার্ম, ল্যাংমোর আইসোথার্ম, ল্যাংমোর অ্যাডসর্পশন আইসোথার্ম আর মাল্টিমলিকুলার অ্যাডসর্পশনস, এগুলো আমরা পড়েছিলাম।
Yes, sir.
ওকে,
Yes, sir.
so can you tell me what are the various application of this adsorption isotherm in pharmacy? What are the various applications of adsorption isotherm in pharmacy? বলো।
Sir, removal of objectionable odor from rooms, or estimation of surface area and particle size of powders.
Yes, very good. And for masking the gas, prevention of obnoxious gases entering into the body odor.
Yes, sir.
Gas mask, all
The
these
gas
are
masks.
yes, but actually the actual application of this adsorption isotherm is the main application, that is estimation of surface area and particle size, that are actually applicable in pharmacy for determinations of surface area and particle size of defined powder, that may be monodisperse or that may be polydisperse powder. So for determinations of surface area and particle size, we can use this adsorption method. Okay, so Freundlich isotherm and adsorption isotherm and multimolecular adsorption isotherm. So the equation and derivation that last class we have studied in detail. So আজকে কি একটু সেটা দেখে নেবে? দেখে নাও। So these are the application: removal of objectionable odor from rooms, prevention of obnoxious gas entering into the body, estimation of surface area and particle size. Okay, so for particle size determination we can also use this adsorption method. So this is all about Freundlich isotherm. What are the main principle of this Freundlich isotherm? কার কার মধ্যে রিলেশনটা Freundlich isotherm ডিটারমাইন করে?
Sir, pressure of the gas and the amount of gas absorbed with the.
And you have to mention another one thing, that is temperature. You have to tell that Freundlich isotherm tells about the relationship between pressure of gas and amount of gas adsorbed on any solid surface at a constant temperature. মনে থাকবে তো? অনেক সময় এরকম জিজ্ঞেস করতে পারে কি what is the meaning of this Freundlich isotherm, what it told, or what is the main principle of this Freundlich isotherm. So you have to tell that Freundlich isotherm is nothing but that is the relationship between pressure of gas and amount of gas adsorbed on a particular solid surface at constant temperature. So it can be expressed by this equation: y is equal to x upon m is equal to k into p to the power 1 upon n. Okay, so here x is equal to weight of gas adsorbed per unit weight of adsorbent, that is m, and p means that is equilibrium pressure, and k and n both are constant. Okay, so for calculations of this x upon m, you have to draw one plot. How? By taking x upon m against pressure P, and constant k and n that can be calculated from that curve. How? First, you have to convert this equation y is equal to x upon m is equal to k into p into to the power upon n. You have to convert this equation into log form. Okay, so you have to convert into log form. So you will get log x upon m is equal to log k plus 1 upon n into log p. After that, you have to plot that curve. See that if you draw the curve just by taking simple pressure in x-axis on y-axis extent of adsorption, you will get a curvilinear plot. From this curvilinear plot, it is not possible to calculate k and n. So for calculations of these both characteristics, that is k and n, you have to convert that equation into log form. And after that, if you draw that curve by taking log p in x-axis and log x upon m on y-axis, you will get a straight line. And if we extrapolate this straight line, it will intersect on the y-axis, and from that intercept value, you will get the value of k, and from the slope value, you will get the value of n. So these both constant k and n that can be calculated from this curve, which you have to draw by taking log p in x-axis and log x upon m on y-axis. Next is Langmuir adsorption isotherm. So all of you know, for derive the equation for Langmuir adsorption isotherm, first you have to do some assumption. What are that assumption? The surface of solid possesses fixed number of active site for the adsorption of gas. So you have to uh, assume that the surface of solid on which the gas will adsorb, it contains some fixed number of active site where the gas will adsorb. Okay, so at maximum adsorption, the gas layer that is found around the solid is of only one molecule thick. This is another one important point, that at maximum adsorption, whatever gas that will adsorb on the solid surface, it will produce only one molecule thick layer. Okay. Next assumption, the rate of adsorption, that is also known as condensation, that is proportional to the number of site unoccupied. অনেকে ভুল লিখে ফেলে, number of site occupied লিখে ফেলে। So you have to remember that the rate of adsorption, that means condensation, that is proportional to the number of site unoccupied. And fourth assumption is the rate of evaporation, that means desorption, that is proportional to the number of site occupied. So after these four assumptions, you can derive the relation between the pressure and adsorption of gas on the solid surface. Okay. Now here pressure is constant. See that at a particular pressure P, in friendly isotherm, what we have seen? At a constant temperature. Okay, here we have taken at a constant temperature. See this one, constant temperature in cases of friendly isotherm. But in cases of Langmuir adsorption isotherm, pressure is constant. Okay. Now, molecule of gas adsorb on active site on adsorbent at a particular pressure P. Now, fraction of active site occupied, for example, that is theta. So, fraction of site unoccupied, that is 1 minus theta. So, rate of adsorption, that is proportional to the pressure, and number of unoccupied site R1 is equal to K1 into 1 minus theta into P. মনে পড়ছে? আগের দিন হয়ে গেছে, তবুও আমি রিপিট করছি because it's very much important. Okay? So fraction of site occupied, for example, that is theta. So fraction of site unoccupied, that will be 1 minus theta. So rate of adsorption, that is proportional to the number of unoccupied site. So if rate of adsorption, that is R1, so we can write R1 is equal to K1 into 1 minus theta into P, and rate of desorption, if rate of desorption, that means evaporation, if that is R2, so R2 is equal to, we can write K2 into theta. Now at equilibrium, this both rate of adsorption and rate of desorption both will be equal. So at equilibrium, if R1 is equal to R2, then by simplifying that equation, we can write theta is equal to K1 by K2 into P upon 1 plus K1 upon K2 into P. Okay. Now assume that K1 minus K2 is equal to B, or theta is equal to Y upon Ym, in which Y is the mass of gas that 1 gram of adsorbent can take up when a monolayer is complete. Now substituting this value K1 upon K2 is equal to B, and Y upon theta is equal to Y upon Ym. If you put this value in these equations, so you will get Y upon Ym is equal to Bp upon 1 plus P into P, or finally you can write Y is equal to Ym into B into P upon 1 plus B into P. Okay. Now plot of P upon Y against P gives a straight line, and Ym and B that can be obtained from the slope value and intercept value. The value of Ym is used to estimate specific surface of the solid, considering that adsorption is monolayer is formed. This you have to remember, that here this Langmuir adsorption isotope, whatever equation you are studying, that is only true when monolayer will be formed. So this is the equation for Langmuir adsorption isotherm. By taking P, that means pressure, in x-axis, and P upon x upon m, that is on y-axis, you will get a straight line, and if you extrapolate, it will intersect on y-axis. From that you will get intercept value. From that you can easily calculate the value of A, and from the slope value, slope is equal to B upon A. So the value of A and B that can be calculated by the help of intercept value and slope value. And this is about multimolecular adsorption. This is also known as BET equation. Okay. Here the layer, in cases of Langmuir adsorption isotherm, Langmuir adsorption isotherm, what we have seen, only monolayer is formed. But this BET equation, that is used when multimolecular adsorption will be there, or means multi-layer will form over that surface of that solid. Next is various examples of different types of adsorption isotherm. See that here I have given total 6 types. Okay, see, so one by one we will discuss about that. First one is type 1. This isotherm, it represents a significant increase in adsorption with increasing pressure. In x-axis you have to take pressure everywhere, x-axis, that is P, everywhere. In every graph, that in x-axis, that is P, that means pressure. Okay, and y-axis you have to take amount of gas adsorbed. So in type 1, see that this is a curvilinear plot. From that plot, what we can say, with increasing pressure, the amount of gas adsorbed on the solid surface, that is also increasing. But after some time, pressure is increasing, but the amount of gas adsorbed on the solid surface, that is not so much increasing, almost same. not so much different. Okay, so this type of isotherm represents a significant increase in the adsorption with increasing pressure, and after that it will leaving off. This leveling off is due to the saturation of available specific chemical group, or the entire surface is covered by monomolecular layer. Here যেমন আমরা দেখেছি in cases of solubility, initially, for example, solubility of sodium chloride in water. Initially, when we will add sodium chloride in water, immediately it will dissolve, and continuously, if you increase the temperature, the solubility of sodium chloride in water that will increasing, and after some time, with increasing temperature also, that solubility, that means sodium chloride, that will not dissolve more. Why? Because the solution that is completely saturated. So same here also, if the solid surface and all that active site whatever that are present on the surface, if that is completely saturated, then no more gas that will adsorb on the solid surface. So because of that, you will get this type of curve, that is curvilinear plot. Initially, with increasing pressure, the amount of gas adsorbed on the solid surface that will also increase, but after some time it will leave off. Why this leaving off? Because of the saturations of whatever active site that are present on that solid surface, and also the formation of monolayer that is completed. This is the same type of curve that already we got in cases of Frenlich isotherm and Langmuir adsorption isotherm. So if anybody asks you what are the examples of this type of adsorptions, so you can say that adsorption of nitrogen gas at 78 degree Kelvin, or oxygen at 83 degree Kelvin on charcoal. Okay. So example is the adsorption of nitrogen on charcoal. Next one is type 2. Type 2, the shape of the curve, see that by taking pressure in x-axis and on y-axis the amount of gas adsorbed, see that the shape of the curve, that is sigmoidal shape. Okay, this type of shape, that is known as sigmoidal shape of the curve. Now the question is, why this type of sigmoidal curve we will get in cases of type 2. This isotherm is sigmoidal in shape, and it occurs when the gases undergoes physical adsorption onto non-porous solid. Physical adsorptions on non-porous solid. A solid that may be porous or that may be non-porous. Last class already I asked that only one plastic material and chalk, on which cases adsorption will be more. Obviously in cases of porous material, because surface area is small, so the amount of adsorption of gas on the porous uh, solid, that will be also more. So the sigmoidal shape of curve that you will get in cases of non-porous solid. See that curve, the first inflections, this first inflections, that point represent the formation of a monolayer. Just a minute. Hello. হ্যাঁ 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 ওখানে ওই সিকিউরিটিকে দিয়ে দিন। হ্যাঁ 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 sorry for interruption. Okay, so this sigmoidal in shape, and it occurs when gases undergoes physical adsorption onto non-porous solid. Okay, the first inflections, see that sigmoidal shape, this S shape. So the first inflections that represents the formation of a monolayer. This portion, this represents the formation of a monolayer. Now, when the pressure is increased further, after that, if you increase pressure further, then monolayer that will convert it into multilayer. So multilayer formation is multilayer formation of gas that will observed. This isotherm is described by which equation? This described this type of multimolecular adsorptions of gas on solid surface, that is described by which equation? BET equations, that already we have studied, that multi-layer formations and condensation within the pores. Okay, now uh, examples of this sigmoidal type of curve or this type of adsorption isotherm that we may see in cases of adsorption of nitrogen on iron. Okay, just you have to remember this one: adsorption of nitrogen on iron or platinum. Adsorption of nitrogen on iron or platinum. In this case, you will get the sigmoidal shape of curve. Okay, next, number 3 or type 3. This is seen very rarely. This type 3, this is seen very rarely. See that, just opposite of type 1. This is type 1 curve. This is type 1 curve. So just opposite of type 1. Okay, so that is type 3. So in cases of type 3, the heat of adsorption of gas in the first layer is less than the latent heat of condensation of subsequent layer. Okay, what I told? The heat of adsorption of gas in the first layer, that is less than the latent heat of condensation of subsequent layer. So in this BET equation, the constant B, that is smaller than 2. And here the example is adsorption of bromine on silica or alumina. What I told? Adsorption of bromine on silica or alumina, that is type 3. Next, type 4. See that curve, type 4. This is the type 4. So in cases of type 4, the plot represents the adsorption of gas on porous solid. First point of inflection extrapolated to the 0, which represents the monolayer or monomolecular layer adsorptions, and condensation within the pores of the solid, and the multimolecular layer is represented by further adsorptions. What I told? This plot represents the adsorption of gas on porous solid. First point of inflection, this point of inflection, so the first point of inflection, this portion, that is extrapolated to the 0, represents the monomolecular layer adsorptions. Then condensation within the pores of the solid, and the multimolecular layer is represented by further adsorptions. Example is adsorption of benzene on silica gel. Okay. Example is adsorption of benzene on silica gel. এগুলো মনে রাখতে হবে example. Adsorption of benzene on silica gel. Next, type 5. This type of curve that is also seen rarely, and it indicates capillary condensation. Okay? Capillary condensations. In this case, the adsorption reaches a limiting value before P0 is attained. Okay? In this case, this capillary condensation, the adsorption reaches a limiting value before P0 is attained. P0, that is pressure. Here, example, as for example, you can say that is water vapor on charcoal. Okay, adsorption of water vapor on charcoal at a particular temperature, that is 100 degree centigrade. So at 100 degree centigrade, the adsorption of water vapor on charcoal, that can be described by this type of curve. Okay, and number 6, that is also we can say that is very rarely. See that first inflections, second inflections, third inflections. So first, second, third. and that is completely different from others. Generally, this is very rarely seen. Generally, this type of curve that may be seen if the uh, solid, that is porous and non-porous, both characteristics if that are present. In that cases we can, and if the pressure fluctuate with time, and also if the temperature is also fluctuating, in that cases you will get this type of curve, that is type 6. Okay. So this is all about the adsorption isotherm and different types of uh, adsorption isotherm with curve. So you have to remember all that. Next one is, before waiting that phenomena, first you have to study about the adsorption at solid liquid interface. That whatever we have studied now, that is the adsorption of gas on solid surface. Now, if adsorption occur at solid liquid interface, in that cases what will happen? The adsorption of gas on solid liquid interface, it is having so many applications. For example, first one, reduced absorptions. Different types of drugs are there, for example, alkaloid, steroid, promethazine, that is, that can be administered with solid such as charcoal or alumina or magnesium trisilicate or aluminum hydroxide gel, that is also known as antacid. Okay, so the absorption of this drug, that is reduced owing to their adsorption on this solid. Okay, so the applications of this gas on solid liquid interface, that is, first application is reduced absorptions. Next, second one is antidote in cases of poisoning. Activated charcoal, I think all of you know this about this. Activated charcoal, that is used as an antidote in the poisoning of tolbutamide or acetaminophen. What will happen? Charcoal absorb all this drug and it will reduce the absorption, thereby preventing their toxic effect. So this adsorption phenomena that can be used in pharmacy as a antidote in cases of poisoning. Next one is purification and reduced toxicity. So this adsorption technique that can be also used for purification purpose also. Activated charcoal, it enhances the diffusion of drug from tissues of GI tract into the GI content. So it will also facilitate the elimination of drugs. But in some cases, drugs which are present in tissue, that will get into systemic circulation initially, and then after that it will release into the GI tract. So drugs that get eliminated from the body by this process. This is also known as gastrointestinal dialysis. I think all of you know. Okay, gastrointestinal dialysis. In this case, what will happen? The drugs that which are present in tissue, that will get into systemic circulation initially, and after that it will release into the GI tract. So the drugs get eliminated from the body by this process. This process is also known as gastrointestinal dialysis. Or also, I think all of you hear about that, that is hemodialysis. So various types of adsorptions are also used in hemodialysis also. The products removed by dialysis which are allowed to adsorb from the dialysis solution. Then the dialysis solution can be recycled for further dialysis process. Next application is reduce the drug content. The adsorption of insulin.
স্যার
হ্যাঁ বলো বলো।
স্যার বলছি আপনি কি স্লাইড চেঞ্জ করেছেন?
না স্লাইড চেঞ্জ করিনি, কেন বলো তো?
মানে আসলে ওই স্লাইডটা দেখতে পাচ্ছি না তো, মানে এই আদার টাইপস অফ অ্যাডসর্পশন আইসোথার্ম স্লাইডটাই শো করছে, মানে এটাই এখন শো করছে তো?
হ্যাঁ এটাই শো করছে। আমি
ওকে
ওগুলো,
ওকে স্যার।
হ্যাঁ ওগুলো আমি ইচ্ছা করে লিখিনি যাতে তোমরা লেখো আমার কথাটা শুনে।
ওকে ওকে স্যার।
নোট
ওকে স্যার।
করতে না কিনা সেটা আমি পরে বুঝতে পারি না, অনেকে চালিয়ে দিয়ে চলে যায়, আমি পরে এই কোশ্চেন গুলো জিজ্ঞেস করবো, এই কারণে আমি,
ওকে স্যার।
হ্যাঁ এই কারণে ওটা আমি স্লাইডে লিখিনি। হ্যাঁ,
ওকে।
so for purification purpose and also to reduce the toxicity, for example gastrointestinal dialysis. In this process also this adsorption technique that is used. ঠিক আছে, তাহলে তিনটে পয়েন্ট বললাম কি কি। ফার্স্ট ওয়ান ইজ রিডিউসড অ্যাবজর্পশন, নেক্সট ওয়ান ইজ অ্যান্টিডোট ইন পয়জনিং, and third one is purification and reduced toxicity. Again I am repeating, the adsorption at solid liquid interface, it is having different various applications. First one is reduce the absorptions, for example antacid, okay, alumina, magnesium trisilicate. Next, second one is antidote in poisoning, the name of drug tolbutamide or acetaminophen. So in cases of this type of poisoning, we can use this adsorption technique as a antidote. Next, for purification purpose and also to reduce the toxicity, this adsorption technique that can be used. So here the material that are used for this purpose, that is activated charcoal. Okay, so already told about that gastrointestinal dialysis, and adsorbents are also used in hemodialysis also. Okay, the product removed by dialysis which are allowed to adsorb from the dialyzing solution, then this dialysis solution that can be
হ্যালো হ্যালো
হ্যালো
হ্যালো স্যার
এই শুনতে পাচ্ছ আমার কথা তোমরা সবাই?
স্যার এতক্ষণ শোনা যাচ্ছিল না, এইমাত্র শোনা যাচ্ছে।
অ্যাকচুয়ালি এখানে কলেজে আছি তো, এখানে পাওয়ার কাট হয়ে গিয়েছিল, নেটটা চলে গিয়েছিল। আচ্ছা, so next one is reduce the drug content, that is another one applications. All of you know, I think the share screen টা করে দিয়েছে, ভিডিওটা লাগবে না। Next one is reduce the drug content, the adsorption of insulin onto intravenous administration set, that has been also reported. Okay, adsorption of insulin. What will happen when insulin that are given intravenously, the before during storage conditions, what will happen, the effective concentration of drug that may be reduced because of the adsorption of insulin on the surface of that container. The preservative phenyl mercuric acetate, phenyl mercuric acetate, this is one examples of preservative that is generally used in eye drop, that will also gets adsorbed onto the polyethylene container and rubber closure. আগে এসে দেখেছো তোমরা যে এগুলো পাওয়া যেত আই ড্রপ গুলো, কন্টেনারটা হতো গ্লাসের, তার উপরে একটা রাবারের একটা ক্লোজার থাকতো, সেটাকে ওপেন করার পর সেখানে একটা ড্রপার লাগিয়ে দিতে হতো, তাই তো? তো in that cases, that during storage conditions there may be chances of the adsorption of phenyl mercuric nitrate, whatever you have used as a preservative. There may be chances of adsorption of this phenyl mercuric acetate on that rubber closure, and if the container is polyethylene, that means polyethylene plastic container, in that cases there may be chances of adsorption of this phenyl mercuric acetate onto the polyethylene container. So all these are the various applications of adsorption at solid liquid interface. Another one adsorption application is there, separation of substance in a mixture. Okay, separation of substance in a mixture. For example, chromatographic technique. নাম শুনেছো কিনা জানি না, chromatographic technique. Chromatography, that is a technique, that is a separation technique. Okay, so this technique that is used to separate the various mixtures of substance, separate a particular substance from a mixture. In this process, adsorption such as alumina or magnesium oxide that are used in a packed column. Okay, alumina or magnesium oxide. When a mixture is passed through that stationary phase, the solute species are adsorbed onto the solid. Okay, so for separations of a particular substance from a mixtures, chromatographic technique that can be used. So all these are the various applications of adsorption in pharmacy. The next one is wetting phenomena. I think this is already also covered. Wetting phenomena. What is the meaning of wetting? Can you tell me what is the HLB value of wetting agent? HLB value of wetting agent. কি বলতে পারবে? সৌরভ কোথায় আজ? সৌরভ?
From 7 to 9.
হ্যাঁ 7 to
9.
yes, very good. That is
Wetting
the
and spreading agents.
wetting and spreading agent. The HLB value is 7 to 9.
হ্যালো
হ্যাঁ সৌরভ, আছো আজকে? শুনতে পাচ্ছ আমার কথা? Okay, so wetting phenomena. What is the meaning of wetting and where it is applied, and what is the relation between contact angle and wetting of the solid surface? See that in industry, large quantity of powder such as talc, charcoal that are added into the water to prepare the different types of formulations. But the main problem is this talc and charcoal, these powders do not get wetted properly in spite of their higher density than water. What will happen if you add talc powder in water? It will not wet and it will float onto the surface. এটা বাড়িতে আমি চেক করে দেখতে বলেছিলাম, তোমরা যদি ট্যালকম পাউডার জলের উপর দাও দেখবে কি হয়, সেটা না ডিজলভ হবে, না ঠিকঠাক ভাবে পুরোপুরি সেটা ওয়েট হবে. What will happen? It will just float onto the surface of that water because wettability of talc that is very, very much less. So wetting that is required for solubility purpose. If wetting is not proper, then solubility will be also less. So both are interrelated. So wetting is the adsorption process in which an intimate contact of the solid with liquid phase is achieved. এই কোশ্চেনটা হয়ে গেছে, তারপরেও আমি কিন্তু এটা রিপিট করছি, ভালো করে শুনে নাও একবার. Wetting is the adsorption process in which an intimate contact of the solid with liquid phase that may be achieved. Now, what are the applications of this wetting phenomena? Why we will calculate contact angle? What are the applications and what are the applications of this wetting phenomena? First one is intimate contact of solid or liquid. That is the first initial step for preparations of emulsion and suspension. Right? For preparations of suspension. What is suspension? If the solid substance that is dissolved in particular solvent completely, then we can say that that is a solution. and if that is not dissolved, then it will form suspension, insoluble or diffusible solids that will be present, and emulsion, that is the mixtures of oil and water. So wetting phenomena is important for preparations of emulsion and suspension. Next, in cases of granulation process or preparations of tablet, the powder mixture that are mixed with liquid binding agent, for example, starch paste, or the solution of alcoholic solution of PVP, polyvinyl pyrrolidone. All these are used as a binding agent for preparations of tablet preparations. So here the mixtures of drugs and other materials that are mixed with this binding agent. So the success of this process that completely depends on the wetting and also the spreading of the liquid over that solid powder. So you have to remember this wetting is very much important for tableting purpose for preparations of granules where the liquid binding agent that are used. Next one is তোমরা দেখে থাকবে বিভিন্ন কালারের ট্যাবলেট পাওয়া যায়, means various colorful tablets are there, colorful capsules are there. So over the surface of the tablet, sometimes coating that is given for different reason. That may be uh, film coating, that may be sugar coating if the drug is bitter in taste, and enteric coating. These three types of coating is possible. So in cases of film coating, it requires the wetting and spreading of the liquid over the tablet surface. Okay, so this is all about the wetting phenomena where wetting is applied. Next is dissolution of tablet or a capsule. It necessitates the penetration of the liquid into the pores of dosage form. So all these are the various applications of wetting in pharmacy. এই এই যে স্লাইডটা আছে এখানে কারো কোনো প্রবলেম বা ডাউট আছে কিনা বলো, কারো কোনো কোশ্চেন আছে? হ্যালো, আছো সবাই, শুনছো না ঘুমিয়ে পড়লে? হ্যালো,
হ্যাঁ স্যার
অ্যাডসেপশন থিওরেমে যেটা টাইপ 5 বলেছিলেন, ওটা মানে যেটা বলেছিলেন লিমিটিং মানে অ্যাডসর্পশন রিচেস লিমিটিং ভ্যালু বিফোর পিও ইজ অ্যাটেন্ড, ওটা আরেকবার একটু বুঝিয়ে দেবেন
ওটা কোনটা বলো তো?
স্যার টাইপ 5 যেটা ছিল।
ও তখন বললে না, টাইপ 5 হচ্ছে কি বললাম ওটা? হ্যাঁ, it indicates capillary condensation and the adsorption reaches a limiting value before P0 is attained. P0 that means pressure. Example হচ্ছে, দেখেছো এক্সাম্পলটা? ওয়াটার ভেপার অন চারকোল at 100 degree
Yes, sir.
centigrade.
Yes, sir.
এই এখন যেটা বললাম ওয়েটিং ফেনোমেনা, এই যে এখন যে ভেরিয়াস অ্যাপ্লিকেশনস অফ দিস ওয়েটিং ফেনোমেনা ইন ফার্মেসি, এটাতে কারো প্রবলেম আছে?
না স্যার।
ওকে, এটা সবাই বুঝতে পেরেছো?
Yes, sir.
Next. Surfactant or surface active agent. Can you remember? কারো মনে আছে কি surfactant or surface active agent?
হ্যাঁ স্যার। হ্যাঁ স্যার।
বলো তো কি বলো তো surfactant?
স্যার রিপিট করুন স্যার, বুঝতে পারলাম না।
What is surfactant? Surfactant কি?
স্যার সারফেক্টেন্ট হলো স্যার এক ধরনের অ্যাম্পিফিলিক মলিকিউল যেগুলো হাইড্রোফিলিক এন্ড লিপোফিলিক বোথ টাইপ অফ গ্রুপ ক্যারি করে, মানে উইথ কন্টেন্ট হাইড্রোফিলিক এন্ড লিপোফিলিক বোথ টাইপ অফ গ্রুপ।
ওটা তো বললে, ওটা হচ্ছে তুমি যেটা বললে সেটা হচ্ছে ওর ডেফিনেশনটা বললে, ওর কাজটা কি? সারফেস টেনশনের
দুটো লিকুইডের মধ্যে ইন্টারফেস স্যার সারফেস টেনশনটা কমানো স্যার, লোয়ারিং দ্য সারফেস টেনশন।
ইয়েস, তাহলে দেখো এই সারফেক্ট্যান্ট দ্যাট অর সারফেস অ্যাক্টিভ এজেন্ট দ্যাট ক্যান বি ইউজড টু ইনক্রিজ দ্য ওয়েটেবিলিটি। Yes or no?
Yes sir.
So surfactant that are used to aid weighting of the powder because they are capable of lowering the interfacial tension or lowering the contact angle between the solid and liquid, and also it will displace the air and permit the intimate contact in between solid and the liquid. Okay, so surfactant that may be added to increase the weightability of poorly water soluble drug or material. So contact angle in this case that can be used as an indicator to evaluate the efficiency of an weighting agent. Okay, so the different types of weighting agents are there. Which one is best? How to evaluate that? So to evaluate the efficiency of an weighting agent, contact angle that may be used as an indicator. Now contact angle, all of you know, that is defined as the angle between the liquid droplet and surface over which it spread. The angle between the liquid droplet and the surface over which it spread. This is the surface, this is the liquid drop. The angle in between the surface of the liquid and the surface on which it spread, that is known as contact angle. So here see that contact angle is more than 90 degree, so the weighting is very much poor, and in this case the contact angle is 15 degree only, so we can say that that is the good weighting, and when the contact angle will be 0, that means that is the complete weighting. So the contact angle value that may be 0 to 180 degree. Same, see that small contact angle, good weightability, large contact angle, bad weightability. Okay, now another one test is there to test the weighting property of weighting agent. What I told, weighting property of weighting agent. One test that may be done to test the weighting property of weighting agent. That test is known as a Dreb's test. Sometime in GPAT that may be asked. So what is the meaning of Dreb's test? So Dreb's test is nothing but that is used to see the weighting property of weighting agent. The time required to sink weight cotton yarn of standard solution. এটা মেথডটা দেয়া আছে। তো ড্রেপ টেস্ট এটা তোমরা গুগলে দিলেও পেয়ে যাবে। What is the principle or procedure for Dreb's test and why it is used? In cosmetic technology also sometimes these Dreb's tests are also used. Okay, so Dreb's test that is used for to test the weighting property of weighting agent. This is the last, that is critical surface tension. Young's equation or Young modulus already you have studied. আচ্ছা, এই ইকুয়েশনটা কোথায় ছিল? ys is equal to ys ls minus gamma s is equal to gamma ls minus gamma l into cos theta. দেখি কে বলতে পারে
work of as and work of calculation, sir.
কি ক্যালকুলেশন করেছিলাম এটা থেকে?
Sir, spreading coefficient.
Very good, spreading coefficient. So here theta is contact angle, spreading coefficient s is equal to এই ইকুয়েশনটা আমরা পেয়েছিলাম gamma s minus gamma l minus gamma ls. Okay, so in this case cos theta is equal to 1. Surface tension when cos theta is equal to 1, that is known as critical surface tension. Okay, so if cos theta is equal to 1, that is known as critical surface tension. ওটা ওখানেও বলেছিলাম, যদি কারো মনে থাকে বা নোট করে থাকো তাহলে তোমরা পেয়ে যাবে ওখানে, critical surface tension. Okay, so this is all about the weighting phenomena and adsorption isotherm. পরের ক্লাসে আমরা একটা নতুন টপিক পড়বো, এটা হচ্ছে ইলেকট্রিক্যাল প্রপার্টিজ অফ ইন্টারফেস। ওকে, তাহলে আজকে এই পর্যন্ত থাক, একটু ওয়েট করো, আমি তোমাদের অ্যাটেন্ডেন্সটা একটু কপি করে নিই।
স্যার,
হ্যাঁ বলো।
বলছি এই 6 নাম্বার টাইপ যেটা ছিল অ্যাবজর্পশনে, ওর এক্সাম্পল কিছু দেননি আপনি, ওটার কোনো এক্সাম্পল?
হ্যাঁ, ওটা তুমি একটু সার্চ করো না, দেখো যে 6 টাইপটা কোথায় পাওয়া যায়। সব
স্যার
তো আমি
হ্যালো স্যার।
হ্যাঁ
স্যার বলছি যে আমরা স্যার লাস্ট যে এক্সপেরিমেন্টটা সাবমিট করলাম স্যার, ওটার ক্যালকুলেশনটা একটু মানে ডাউট আছে।
হ্যাঁ, ওটা ফ্রাইডে, যেমন প্রত্যেক ফ্রাইডে আমি যেমন ওটা প্র্যাকটিক্যালটা নিয়ে তোমাদের একটু বলে দিই। এই ফ্রাইডে এলে আমি ওই সব পুরো দুটো রিটার্ন কোএফিসিয়েন্টের প্র্যাকটিক্যাল আর আরেকটা হচ্ছে তোমার এইচএলবি, ওটা ওই দিন আমি পুরো ডিসকাস করে দেবো শুক্রবার দিন। ঠিক আছে? হ্যালো।
হ্যাঁ স্যার।
ওকে
হ্যাঁ
স্যার।
শুক্রবার দিন ওটা আমি করে দেবো। আর তোমাদের হয়তো মেবি চান্সেস আছে হয়তো ডিসেম্বর থেকে তোমাদের কলেজ হয়তো আসতে হতে পারে। ঠিক আছে? তো যদি হ্যাঁ প্র্যাকটিক্যাল তোমাদের করানো হবে ডিসেম্বর, কারণ ট্রেন তো জানো তোমরা, ট্রেন চালু হয়ে যাচ্ছে, তাই হয়তো তোমাদের কলেজ হয়তো চালু হয়ে যাবে ডিসেম্বর থেকে, এবং তোমাদের আসতে হবে প্র্যাকটিক্যাল করতে। তো তবু আমি সবকিছু ওটা করিয়ে দেবো বা যতগুলো সম্ভব, কিন্তু তোমাদের হয়তো প্র্যাকটিক্যাল করতে আসতে হতে পারে ডিসেম্বর থেকে। ঠিক আছে? তোমাদের জানিয়ে দেওয়া হবে কিরকম কি টাইম টেবিল বা হোয়াট এভার। ঠিক আছে?
ওকে স্যার।
তো হ্যাঁ, তো আমার মনে হয় সেটা ম্যানুয়ালি তোমরা যখন করবে সেটা আরো বেটার হবে। আচ্ছা, আমি তোমাদের এটা
স্যার
শেয়ার
তার
করে দিই।
মানে আমাদের পরের যে ইন্টারনাল গুলো হবে ওগুলো অফলাইনেই হবে, পেন পেপারে, তাই তো?
আশা করা যাচ্ছে, তাই ভালো করে পড়ো। দেখো তো ফর্মটা ওপেন হচ্ছে কিনা যেটা দিলাম। তবে দেখতে পাচ্ছ ফর্মটা?
হ্যাঁ স্যার, দেখা যাচ্ছে।
ওপেন হয়েছে তো?
স্যার
বলো।
বলছি, আপনি ফার্স্ট পয়েন্টে যেটা বলেছিলেন অ্যাবজর্পশন অফ নাইট্রোজেন অন চারকোল অ্যান্ড অক্সিজেন অন চারকোল,
হুম
ওখানে দুটোই আলাদা আলাদা টেম্পারেচার মেনশন করেছিলেন, ওটা আরেকবার বলে দেবেন?
কোনটা বলো তো?
ওই অ্যাবজর্পশন অফ নাইট্রোজেন অন চারকোল আর
হুম
অ্যাবজর্পশন অফ অক্সিজেন অন চারকোল,
হুম
ফার্স্টে এক্সাম্পল দিয়েছেন না কার্ভিলিনিয়ার, যেটা টাইপ 1?
প্রথমেরটা হচ্ছে অ্যাডজর্পশন অফ নাইট্রোজেন, সেটা হচ্ছে 78 ডিগ্রি কেলভিন টেম্পারেচার, আর অক্সিজেনটা হচ্ছে 83 ডিগ্রি কেলভিন।
83 ডিগ্রি স্যার সেলসিয়াস বললেন তো? 83
কেলভিন
70
কেলভিন
কেলভিন,
কেলভিন
দুটোই কেলভিন? ও আচ্ছা, ঠিক
ঠিক আছে। হ্যাঁ, ঠিক আছে, তাহলে এখানে শেষ করলাম আজকের ক্লাস।
Thank you, sir.
ওয়েলকাম।